fundamental forces in nature. Children, as all of you know that there are four fundamental forces in nature. They are gravitational forces, electromagnetic forces, strong nuclear forces, and weak nuclear forces. Among all these four fundamental forces in nature, the strongest forces are nuclear forces and the weakest forces are gravitational forces. Okay, let us try to know what are strongest nuclear forces and what is its role in forming the nucleus. Okay, basically nuclear forces are those forces which hold the nucleons inside the nucleus. What are nucleons? Neutrons and protons are collectively called nucleons, and these nucleons are existed inside the nucleus. As all of us learned that in an atom, the central part of the atom is nucleus, and around the nucleus electrons are revolving. The size of the atom is around 10 to the power of minus 10 meter approximately, whereas the size of nucleus is about 10 to the power of minus 15 meter. It's very, very small. The central part of the atom is nucleus, and this nucleus contains protons and neutrons, which are known as nucleons. And these nucleons are strongly held by a kind of force known as strong nuclear forces. And these strong nuclear forces are short range forces. They are always attractive forces, even though between the proton and proton, proton and neutron, and neutron and neutron, there exists a force which is known as strong nuclear forces. Even though proton is a positively charged particle, and this proton is also a positively charged particle, but according to their nature, there must be a repulsive force. But at a smaller distance, the attractive force overcomes the repulsive force. So, between the proton and proton, proton and neutron, there exists a force inside the nucleus. At a small distance, that force has attractive nature. Even this neutron is held by nuclear force. It means these nuclear forces are not depending on charge. They are charge independent. But they are spin dependent. Suppose if one neutron is rotating like this, another neutron is rotating like this, there is an attractive force. But here, the spin of the particles are opposite. Whereas, if you consider one neutron and the other neutron, the spinning is in the same direction. But here, this force is different from this force. So, the nuclear forces are spin dependent and they are independent on charge, and these nuclear forces are non-central forces. Non-central means they do not act along the line of joining the two centers. Here is a neutron and here is a neutron. They do not act along the line of joining the two sectors. Whereas the gravitational forces are central forces. They act along the line of joining. So this is all about the strong nuclear forces. Now let us move on to electromagnetic forces. What are electromagnetic forces? As all of us know that Coulomb was the first scientist who discovered electric forces between the two charged particles. He said that the electrostatic force or the electric force between any two charged particles, Q1 is the magnitude of the first charge, Q2 is the magnitude of the second charge. They may be positive or they may be negative, or one may be positive, the other one may be negative, and they are separated by a distance r. The electric force between these two particles is directly proportional to product of the magnitude of the charges and inversely proportional to square the distance between them. Combining these equations and keeping this proportionality constant as k, we can write that Q1 Q2 divided by r square. This k is known as proportionality constant, whose value is 1 by Q naught. Fine. These electromagnetic forces existed between two charged particles. As all of us know that there are two charged particles, a proton and an electron. Proton is a positively charged particle, electron is a negatively charged particle, and between the two charges there exists a force known as this electromagnetic force. This electromagnetic force may be attractive or repulsive depending upon the nature of charges. If there is a positive charge and a negative charge, the nature of force is attractive. If both are negative or if both are positive, the nature of force is repulsive. And as all of us know that these charges act over a large distance, and these are weaker than strong nuclear forces but stronger than weak nuclear forces. What is the importance of electromagnetic force? Electromagnetic forces are responsible for the structure of molecules, the structure of atoms. The matter is existed due to electromagnetic forces. Fine. Now let us move on to the next type of forces, that is weak nuclear forces. What are weak nuclear forces? These weak nuclear forces are found during the decay process. As we know that a radioactive element emits three kinds of radiations. Madame Curie discovered radium. The scientist Becquerel discovered that the radioactive element emits three kinds of radiations. That is alpha radiations, beta radiations and gamma radiations. Alpha particle is nothing but a helium nucleus. Beta particle is nothing but an electron or positron. Gamma particle is nothing but a photon. If a heavy radioactive nucleus like uranium, thorium, they emit these kind of radiations, not the lighter nuclei. The heavy nuclei which contains more number of neutrons than protons. The heavy nucleus is unstable. The one which is unstable, it emits three kinds of radiations. And during this beta decay or the nuclear decay, the weak nuclear forces are existed. What is exactly happening inside the nucleus? There is a conversion of neutron to proton and proton to neutron. During this conversion, this decay process takes place. Okay. So these weak nuclear forces, here we go, backside. These weak nuclear forces are responsible for nuclear decay. Weak nuclear forces are existed between two elementary particles. They are very short range forces. Electrons and neutrinos interact with each other through weak nuclear forces. Okay, now let us move on to the next type of forces, that is gravitational forces, which is very important. And this gravitational forces is responsible for the formation of universe, the existence of universe. These gravitational forces basically was discovered by a scientist known as Sir Isaac Newton. He says that between any two pieces of matter in this universe, there exists a gravitational force. And the amount of force that is existed between any two matters is directly proportional to product of the masses and inversely proportional to square of the distance. Larger the masses, larger would be the force. Smaller the distance, larger would be the force. So combining, we can write that G into m1 m2 r square. This G is known as gravitational constant. This formula, this expression was given by Sir Isaac Newton. Fine. These gravitational forces are weakest forces among all the forces. They act over a very large distance. That is distance between sun and earth, moon and earth, and they are always attractive. They cause for the motion of planets around the sun and tides that occur in the sea due to gravitational forces. The moon is revolving around the earth due to gravitational force. It's very important. The gravitational force is very important in explaining the structure of the universe. So, these are the fundamental forces in nature. Now, let us compare this gravitational force is how many times weaker than the electromagnetic force, strong nuclear force, or the weak nuclear force. Yes, here the weak nuclear force is a 10 to the power of 25 times. The weak nuclear force is a 10 to the power of 25 times stronger than gravitational force. And that electromagnetic force is a 10 to the power 36 times stronger than gravitational forces. And strong nuclear forces is about 10 raised to 38 times stronger than the gravitational forces. With this, we learned about the fundamental forces in nature.